We are now going to get introduced to the graphs of sine and cos. And these are graphs that are periodic because they repeat themselves. Now you might remember that sine was your y-coordinate and cos was your x-coordinate. So if we were going to graph sine and cos, and I've got a little program here, we can zoom in a little bit so that you can see this. This is pretty good. What this program allows me to do is graph any trig function that I want. So we're going to start with graphing cos. Now on this little unit circle here, cos is always your x-coordinate. So when your angle is 0, can you see that my x value is 1? So I've got, turn sine off, I've got a red dot there for cos. And as I drag this point around the unit circle, can you see that that red line to the x-axis is getting smaller and smaller? And then when we go into quadrant 2, now my x-coordinates are negative. In quadrant 3, they're still negative. In quadrant 4, they're positive again. And if you would keep going, it would just repeat this shape over and over again. Because once you go past 2 pi, your angles are just coterminal, and this is the shape of your cosine graph. If we look at our sine graph, remember that sine is your y-coordinate. So if I add sine onto this and start dragging it, well, my y-coordinate is 0. Now that I'm going up, that blue line on the unit circle, that represents my y value. And so now it's at equal to 1. And now it's that y value is coming back down again. Y value is increasing. And now your y values are decreasing again. But in quadrant 3 and 4, you can see that your y values are negative. Quadrants 1 and 2, your y values are positive. So the blue graph is your graph of sine. Now what I'd like you to do is I would like you to draw, we'll start with sine here. Take out your notes. On the side of page 514, they have the graph of sine as well at the bottom, but I would like you to draw your graph of sine like this. What we're always going to do is we're going to divide our sine graph into our 4 quadrants, our axes family, pi over 2, pi, 3 pi over 2, and 2 pi. And sine of 0 we know is 0. Sine of pi over 2 on our axes family is equal to 1. Our y-coordinate is 1. Sine of pi is 0 again. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. So we're going to split this up into our 4 quadrants. Sine graph will start in the middle of our graph, then go to a maximum, back to the middle, down to a minimum, and back to the middle again. And the maximum value is 1, and the minimum value is negative 1. And you can draw this shape, put arrows on the end to say that this continues, because if you went around the second time, this graph would keep going in its shape and repeat itself over and over and over again. Some things that we can describe. So taking out our highlighter to highlight some things in our notes here. Well, any graph that repeats itself over its domain is called a periodic function. The time that it takes to repeat itself is called the period. And so we can take any point on the graph. And on the diagram here, they said if you start at this minimum, how long does it take to get to this minimum? That's 1 period. You could also, if you want to find a value that's even easier to calculate, you could start at this value. Here, I'm starting in the middle of my graph going up. When do I get to that again? Well, here I'm in the middle, but I'm going down. It doesn't repeat itself until here. Can you see that this distance from here to here is 2 pi? Or 360 degrees if you were dealing in degrees. So we'll say that the period of this function is 2 pi. You can highlight that as well if you want to highlight that in your notes. Sine has a period of 2 pi. Describing some characteristics of our sine graph. If we wanted to say, what's the domain of our sine graph? Well, it's everything. Our domain is everything. How do we find the zeros? The zeros are the x-intercepts. So if we're looking at our graph, we have an x-intercept here, 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 and they would keep happening because it's periodic. We would have a lot of them, an infinite amount, because it continues forever. So how do we write them all down? Well, if you start looking at the ones that we have, we've got 0, pi, 2 pi. If we kept going, we'd have 3 pi and so on. We've got negative pi, negative 2 pi, and they keep going in that direction. How do we write them all? Well, in your textbook, they've written them as 0 plus or minus pi plus or minus 2 pi, just like this. But if we wanted to write them all, we have to use the same formatting that we do for our coterminal angles. We look for a pattern. Can you see that this is including all of the whole number and negative whole numbers, or all integer multiples of pi? 1 pi, 2 pi, 3 pi, 4 pi, negative 1 pi, negative 2 pi, negative 3 pi, negative 4 pi. So we can show that as, wow, any number times pi, and then explain that that number in front is an integer. And that's the way that you can write all of the x-intercepts in one statement. This function has a minimum value of -1, or sorry, maximum value of 1, a minimum value of -1, and so its range is between -1 and 1. That's our sine graph. We're going to do the same thing with our cosine graph. So I want you to draw it again, separate things in between 0 and 2 pi. Cos is your x-coordinate on your unit circle. So when you run through your axes family, cos of 0 is 1. Cos of pi over 2 is 0. Cos of pi is -1. Cos of 3 pi over 2 is 0. And cos of 2 pi is 1 again. In fact, the cos graph and the sine graph look identical. They're just translations left and right of each other. Now, again, the reason I get you to graph it separately like that is because the graph paper that they've used makes it hard to see. These are the only points that you're going to need to be able to draw it, and those points are on your axes family. Again, the period is how long it takes to repeat itself. And the period of cos, since that graph is identical to your period of, identical to sine, just shifted left and right, its period is going to be the same. So again, they started from the minimum here and said, how long does it take to go from one minimum to the other? And you'd have to count what's the distance between -pi and pi. It might be easier to start at 0. Here I'm at a maximum. When's my next maximum? It's at 2 pi. So from that, it's really easy to see that the period is 2 pi. The domain of the cosine function is everything, just like the domain of the sine function is everything. Now, for the zeros of cos, again, it's going to be easier if we look at our graph that we drew. Can you see, if we started listing our zeros, for our positive ones, we have pi over 2, 3 pi over 2. What's our next one going to be? Right here. Five pi over 2. And then the next one, 7 pi over 2. And similarly, if you went in the negative direction, you would have negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, and so on. So we have to come up with a way, how do we write all of these zeros? Now in your textbook, they've written, oh, this is not the one, they've written it this way. How do we come up with this? Because the idea is you should be able to graph it, and with graphing it, you're going to be able to see exactly this, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So we need to come up with a way to write those zeros each and every time. We need to look for a pattern. To start off with that pattern, can you see that your zeros, if we were allowed to use words, that it was always an odd number times pi over 2. Does that make sense? Unfortunately, mathematically, they don't like you writing words. We need to come up with a mathematical way to write an odd number. So how do we write an odd number? Well, if you take any integer, those are like 1, 2, 3, 4, 5, or negative ones. If you take any integer and multiply it by 2, does that make sense that that would give you an even number? 2 times anything gives you an even number. So if I want an odd number, if I have any even number and I add 1, does that make sense that that would give me an odd number? So if I want to write odd numbers times pi over 2, this will be odd times pi, all divided by 2. And again, k can be any, any integer. This is one way that you could write all the zeros of cosine. Another way that you could write all the zeros of cosine is by noticing that as we hop from one zero to the next, all we're doing is adding pi. So if I wanted to list all of the zeros of cosine, I could start with one of them. I could start with pi over 2, and then I could say I could add pi or subtract pi as many times as I wanted, where k is an integer. That expression means the same thing as the first one. So the first one, we looked at the pattern and we said they're always odd numbers of pi over 2. So how do I write an odd number? 2k plus 1 times by pi over 2. The second method is I want to start with this one, and if I want to find all the other ones, all I have to do is add or subtract pi as many times as I'd like. So I start with pi over 2 and add pi or subtract pi where k is any integer as many times as I like. We'll add them all together. Again, the maximum value of 1 and minimum value of -1, just like before. And the range is the same as a sine graph. So that's our cosine graph. Now, in both our sine graph and our cosine graph, some other definitions. We define the amplitude as the distance from the maximum or minimum point to the center line. So the center line is what's right in the middle, and your amplitude for both your sine and your cosine graph will be 1. Your new English word of the day, sinusoidal. Sounds like some sort of thing that you need to blow your nose a lot. Both sine graphs and cos graphs are called sinusoidal functions. When we graph things, we're often going to put a dotted line for our center line. And our center line for our sine and cos graph is at y equals 0. Of course, we're going to do all the transformations that we did with our other graphs, with our sine and cosine graphs as well. So we're going to have to get used to how we use the amplitude, how we use the center line, a period, to graph our functions. Because we're going to use, instead of using our transformations from left to right, we're going to use these characteristics to help us graph it quicker. So what we're going to do in this first section, when we get to example 1 here, is although it says just to determine the amplitude of the graph of each of these functions, we're also going to graph them. And we're going to find out certain characteristics of the graph. So here we've got in A, y equals 2/3 sine x. So if we were thinking about our transformations, we've got a 2/3 in front of sine of x. Would that affect it horizontally or vertically? Hello? So the 2/3 in front is going to affect the graph vertically, and it's going to be a vertical compression. So if we think of our normal sine graph had a maximum value at 1 and a minimum value at -1. When we multiply it by 2/3, our maximum value now is going to be at 2/3, and our minimum value is going to be at -2/3. So in part A, our center line is still going to be at 0. So in part A, our amplitude is going to be 2/3. Amplitude is always positive because it's the distance from the center line to the maximum or center line to the minimum. If I wanted to graph this, what we're going to do for graphing is we're always going to label one period on our x-axis. So the period of sine is 2 pi. We're going to divide it into 4 equal sections, which match up, in this case, with our axes family. And our sine graph always starts on our center line going up. So it goes from center line to maximum, back to center line, to minimum, back to center line. And we can draw our graph going through those points. One of the things that we're going to find out in this unit is that whatever your vertical stretch or compression, whatever your value in front of your sine or cosine graph, will always match up to be the amplitude. So when we go to part B, In part B, we've got a negative 4 out in front. Well, if our maximum was 1 and we multiplied that by negative 4, that'll change it to negative 4. And if our minimum was negative 1 and we multiply that by negative 4, we'll get a maximum of 4. And so our amplitude, because our center line is still at 0, our amplitude is going to be 4. For a cosine graph, just like sine graph, we're going to mark our period. We're going to divide it into 4 equal sections. And our cos graph normally started at a maximum, but can you see with that negative 4 out in front, that would be a vertical reflection and a vertical stretch? So if it started at the maximum and you reflected it over the x-axis, it'll start at the minimum. And the reason we split it into 4 equal sections is because your sine and your cosine graphs are always going to alternate. So minimum to center line to maximum to center line to minimum again. And we can draw our graph. So, some questions to practice. We'll take a few minutes to try these ones now. 3a, 4, 5, and 9.